exactly like solving a quadratic equation. Other parts of this are going to, well, look absolutely crazy. But technically, we have all the tools we need to solve these weird-looking equations. So let's start off with something easy. For example, I want you to solve 3x to the fourth plus 3x to the third is equal to 18x squared. This isn't bad. This is not a quadratic equation. Why? Well, the degree is 4, it's not 2. But it has some similarities to a quadratic equation. It has 3 terms. And that's another recognizable feature of quadratics. They have 3 terms and they're generally equal to 0. So take a guess what you're going to do first. Not yet. Get it equal to 0. So you get 3x to the fourth plus 3x to the third minus 18x squared is equal to 0. If I copy this down. Yeah. All right, and now you can pull out x squared. 3, 2. Pull out the whole GCF. So you pull out a GCF of 3x squared, left behind. X squared after you do the division. X and minus x. So inside of this was a hidden quadratic, the x squared plus x minus 6. So keep on factoring and you get 3x squared, and this factors nicely. Factors of 6 that subtract up to 1. 2 and 3. So this is x2, x3. You just got to figure out the signs. Well, that doesn't make any sense, does it? Didn't I say subtract up to 1? Yeah, never mind. No, wait a minute. Hold on.
Minus 2 plus 3.
No, my brain's just someplace else. I don't know where. Plus 3 and minus 2. I was thinking of 3 things at once, and I shouldn't be doing that.
What if it doesn't factor out?
Quadratic formula. Yes, that would be horrible. Well, not too
Well,
bad.
that's because I know I was looking at all this association.
If you couldn't factor this, I would go with quadratic formula, because the middle number is not even. If it was x squared plus 2x and it didn't factor, I'd do complete the square. But if it doesn't factor, but this type, it'll factor. All right, what are my solutions? Well, you set each one of the factors equal to 0. So if I set 3x squared equal to 0, when's that equal to 0?
Huh?
Should I write it? 3x squared equals 0.
0.
When x is equal to 0. It's the only time it's equal to 0. When does x minus 2 become 0?
2.
At positive 2. And x plus 3?
Negative 3.
So this one actually has 3 solutions. Interesting. And that's it. Which part? Set each one of the factors equal to 0. These are 3 numbers multiplied together to give you 0. One of them has to be 0. Otherwise, it wouldn't equal 0. So you set 3x squared equal to 0. The only thing that solves this is x is equal to 0. 3 times 0 is 0. The only thing that makes this equal to 0 is a positive 2. And the only thing that makes this 0 is negative 3. And that's the easy one. A little harder. Something called quadratic form. Quadratic form. Now, quadratic form is something that looks like a quadratic. So this actually falls under the title of quadratic form. It's something that looks like a quadratic. It was actually hiding a quadratic, and we could solve it in that fashion. This gets a little stranger. For instance, if I have 6x to the fourth plus x squared minus 2, and it's equal to 0. Now, this is not a quadratic equation, but it has properties of a quadratic. It has 3 terms, and most importantly, if you take the middle term and square it, it gives you the first variable. What's x squared squared? X to the fourth, and that's the main reason this is in quadratic form. If you take the middle variable and square it and get the first variable, it's considered quadratic form. So what we're going to do is we're going to force it to look like exactly a quadratic equation using this little trick. It's called a U substitution. I'm going to let a new variable equal something in this equation. And what I'm going to let it equal is the middle variable. Not the coefficient. I don't care about the coefficient. I'm talking about just the middle variable. So in this case, I'm going to let u equal x squared. And then I'm going to square both sides of this little equation, and I'm going to get u squared is equal to x to the 4th. So using this, I can do substitution. And what I'm going to substitute away is, wherever I see x squared, I'm going to replace it with u. Wherever I see x to the 4th, I'm going to replace it with u squared. So this becomes...
How do you know? Why can't you play it with like x and then x squared?
Because I already have an x.
Yeah, but you just can't see u.
Yeah, but I can't use the same variable because x can't equal x squared, except for two cases, 0 and 1. You see what I'm saying? You can't set up an equation substituting away a variable with the same variable. You have to choose a different variable. I just chose u. You can choose anything, n, e.
Why not just leave it as x now? X is a variable.
I know, but I don't see this as a quadratic. I don't know how to deal with this because it has x to the 4th. And later, they're going to get worse. Much worse. So, you use u, you let it equal the middle variable. You square both sides of that little equation. Replace x squared and x to the 4th with u and u squared. So this becomes 6 u squared plus u minus 2 is equal to 0. Standard quadratic equation in terms of u. In terms of u.
Yes, well, why can't you do it in terms of x?
You could, but there's some that you can't.
Okay.
That's what I'm trying to say. This is a simplistic version. I'm just trying to get you used to the substitution part. Wait till I change those variables a little bit weirder. So, how do I solve this equation?
Yeah.
Oh, it's a quadratic. The best thing is get it equal to 0 and it's already there.
So we factor.
Try to factor it. Does it factor? I don't know. Let's find out. Factors of 6 times 2, better known as 12. Are there factors of 12 that subtract up to 1? 3 and 4. So which way do you want me to do this? Shortcut or the long way? Long way. So split this up into 3 and 4. So this will be 3u, this will be 4u. There's a minus 2 at the end, and there's a 6u squared in the front. What kind of 3u, what kind of 4u? Gives you a positive 1u. Negative 3, positive 4. So you spread it out into 4 terms, and you group and factor. So you group the first 2 terms together, what can you pull out? A 3 and a u. What's left behind? 2u minus 1. Remember, you're dividing it out. So you get 3u divided by 3u is that 1. All right, what's the GCF of the second 2? Take into account the sign. Positive 2. Can I pull out a u? Heck no. So it's positive 2. What's left behind? 2u minus 1. This method works great because you can see that you did it absolutely right because those have to be the same. The 2u minus 1 and the 2u minus 1. What can I kick out now? 2u minus 1. What's left behind? 3u plus 2. Now, after all of that gobbledygook, I forgot something. Equal 0. We're not just trying to factor this, we're trying to solve it. It was an equation to begin with. All right, so what are the solutions? Now, 2u minus 1 better equal 0, therefore u better equal a half. And over here you get 3u plus 2 is equal to 0, so 3u is equal to negative 2, and u is equal to negative 2/3. Great. Am I done? Why? What up? You?
The part you pulled out first.
What parts?
Like, you know how you have like the 3u, when you pull out a number, do you have to set that equal to 0?
See, this is a plus. You can't do that until you have a times, so you have to get it into factored form. Once you get into factor form, then you can set the pieces equal to 0. But having a plus b is equal to 0, there's many ways of doing that. 4 plus -4, 5 plus -5. So there's no exact way, except getting a multiplication. But am I done with my problem? Is my answer 1/2, -2/3? The answer is no. Because these are u equal. What am I really trying to solve for? X. I have to undo my substitution. So to undo my substitution, go back up here, I have found that u is equal to 1/2, and u is equal to -2/3. But I need it in terms of x. So how do I replace u? What's u equal to? X squared. You have to go back to the first substitution you made up here. So replace u with x squared, and you get x squared equals 1/2, and x squared equals -2/3. And solve both of those little equations. How do I solve the first one? Square root both sides. And x equals plus or minus 1 over the square root of 2. Which part?
Up there, top.
U equals 1/2?
I got you. Yeah, I got that from down there.
Right. But we're trying to solve this equation, an original equation, and the original equation has
X squared.
x. It has an x in it. So we're trying to solve for x. So I have to convert u's back into the variable I'm trying to solve for. The only thing that does that is u is equal to x squared. So wherever I see a u, replace it with x squared. But then I get a new equation where x squared is equal to 1/2, so x is equal to plus or minus 1 over square root of 2, also known as square root of 2 over 2. All right, how do I solve the other one? Square root both sides.
X equals I.
Plus or minus I. Yeah, this gets a little uglier. Square root of 2/3. I would let you leave it like that, except I really should teach you what it should be written as. This one, how do I rationalize the denominator? What do I need to multiply by? Square root of 2, top and bottom. So you multiply square root of 2, top and bottom. This becomes plus or minus square root of 2 over 2. Ooh, 2. Oh, I was thinking 3. Over, probably because I was over here. Over here, how would you rationalize this one? It's not as pretty. First off, you can't have a fraction underneath a radical. So you take the square root of the top and the square root of the bottom. So that becomes square root of 2 over square root of 3. How do I rationalize that? Multiply top and bottom by the square root of 3. So this becomes the square root of 6 over 3. Don't forget the I. Don't forget the plus or minus.
Why wouldn't you do the conjugate?
Conjugate works with binomial pieces. This is a single term, so you just multiply by a single term. If it was 2 plus the square root of 3, then I would multiply by 2 minus the square root of 3. But if it's a single term, you're just getting rid of that one complexity. All right, final solution. X is equal to, how many solutions do I have?
3. No, 2.
4. Plus or minus, that's 2 solutions. Plus or minus, that's another 2 solutions. So this is the square root of 2 over 2, negative square root of 2 over 2. So that's plus or minus the square root of 2 over 2. And the second one is going to be I square roots of 6 over 3 and negative I square roots of 6 over 3. Now generally this quadratic form is going to be a little bit messier than just a regular old quadratic equation because it pops out a few weird answers every once in a while. Is that crazy? Yes. Will I still ask it on a test? Heck yeah. And that's the easy one. That's the easy one. Let's make it a little bit harder. Not harder actually mathematically, but for most people it just, the way it looks makes it harder. I don't know why. So y to the 4/3 minus 12y to the 2/3 plus 32 is equal to 0. Remember what I said about those variables getting ugly? They're ugly. Does everybody remember what 2/3 power means?
No.
Good. Let's refresh your memory.
What? Wait. Oh. I didn't literally. Like,
I didn't erase that much. Okay, on this side though. Oh, I should have. If you have 27 raised to the 2/3 power, 27 raised to the 2/3 power, the number on top tells you to square it. The number on the bottom tells you what root to do to it. So this is a cube root, and then you're going to square it. So this is the cube root of 27 squared. It's easier to make this number smaller than to make the number bigger. What's the cube root of 27?
3.
And 3 squared? 9. So 27 to the 2/3 power is just 9. Now 4/3 power gets just a little uglier. That would be 27 to the 4/3 would be the cube root of 27 raised to the 4th power. You'd get 81 out of the mess. Alright. So under the same conditions as the last one, what substitution would you make? Let u equal the middle variable, y to the 2/3. And then after you choose that little substitution, you take both of them and you square them. If this is going to work as a quadratic form, that squared term better be y to the 4/3. So, is y to the 2/3 squared y to the 4/3? Down here. Y to the 2/3 squared. What do you do with a power to a power? Multiply. Base times base, you add the exponents. Power to a power, you multiply them. So 2/3 times 2 is 4/3. 2 times 2 is 4. 1 times 3 is 3. You get 4/3. So this actually turns into y to the 4/3. If it didn't, we'd be in a bit of trouble. Okay, so do your substitution. Y to the 4/3 becomes u squared. So you get u squared minus 12 times y to the 2/3 becomes u. So you get minus 12u. And then finally plus 32, and it's equal to 0. Now out of these two equations, which one would you rather look at? The second one. That's why the u substitution is nice. It takes something that's ugly and changes it into something that's a little bit, well, nicer. Okay. Factors of 32 that add up to 12. 4 and 8. So we're going to get u of 4, u and 8. What kind of 4, what kind of 8? And both of them negative. So far so good? This one actually looks nicer than the last one. So this one says u is equal to 4, and the other one says that u is equal to 8. Set u minus 4 equal to 0, set u minus 8 equal to 0, add 4, add 8, and you get those two solutions. But the problem is, I'm not trying to solve for u, I'm trying to solve for y. In this case, y. So I need to unsubstitute. So what was u equal to begin with? Y to the 2/3. So this becomes y to the 2/3 power is equal to 4. And over here you get y to the 2/3 power is equal to 8. And then the fun begins. Okay. Little side note. When you solve this equation, how do you solve it? Square root both sides. And the square root and the square kind of, well, cancel, right? Except for, you have to add the plus or the minus.
Where are you getting x squared from?
I'm just making this up. This is a side note, like the 27 over here. It had nothing to do with the problem, but I'm trying to show you what to do with powers. If you had x cubed is equal to 27, what would you do? You would take the cube root of both sides, because a cube root and a square, cube root and a cube are going to cancel. Now the question becomes why? I know we've been doing it, but there has to be a reason.
Just like part of the square.
Why? Well, it has something to do with that. Second part. If it was square rooting both sides of the equation, we have to tag in plus or minus. If we cube root both sides of the equation, do we need plus or minus? No, because you can take the cube root of -8, which is -2. It's perfectly fine. So even powers you have to be careful with. Odd powers you don't have to be very careful with. Okay, so why does the cube root and the cube cancel? Well, what's another way of writing the cube root of x as x to some power? 1/3. It's x to the 1/3 power. So if you take x to the 1/3 power and you raise it to the 3rd power, what happens with your powers? Well, you multiply them. 1/3 of 3 is 1. So that just pops out the x. That's why they cancel each other. Okay, so with that idea under our belt, how do I get rid of a 2/3 power? I can cube it, but then there's the 2 left over. Let's do that. Let's go the long way. Cube both sides. What does that do? Well, this becomes y to the 2nd power is equal to 4 cubed. Without a calculator, cheaters. 64. And over here, if we cube both sides, we get y squared is equal to, and I don't know what 8 cubed is. 624, I don't know. 512. Alright, but I still haven't solved it. What do I have to do to both sides then? Square root it. Now this is where you have to be cautious. We're square rooting both sides of an equation, so the first thing I'm going to write on the other side is plus or minus. So this one becomes y is equal to plus or minus 8. That's the nice one. Comes out perfect, square root of 64. The not so nice one is over there. This is going to be y is equal to plus or minus... Don't give me decimals. Can it break down?
Yeah.
Let's find out. 512. Smallest number that goes into it. 2. And what?
256.
256. Which is 2 and 128. Which is 2 and 64. Which is 2 and... Well, let's stop there. 2 and 64, right? 64 is a perfect square root. I can stop there. So it's 2 times the square root of 64, better known as 8. 2 times 8 is 16. And then that 2 kind of hangs out on the inside. So this becomes 16 square roots of 2. There's other ways of doing it, but that's probably the one. What? Say again?
I thought it was the other one.
What do you mean?
What is 16? I thought it was
16? I could... should I just do the whole thing? It takes too long. You get a factor of 2 from here. This is 64. The square root of 64 is 8. 8 times 2 is 16. And then what's left behind is the square root of 2. But if you broke 64 down, you'd find out that you could group a lot of things. Specifically 3 more groups of 2. So, the answer to this, after all of that, is y equals... How many answers?
4.
4 of them. 8, negative 8, 16 square roots of 2, and negative 16 square roots of 2. Ah.
What was the other way you were going to show before I said cube root?
Oh, the other way I was going to do it? If you have y to the 2/3 is equal to 8, you could take both sides of this equation and do it in one step. The problem is, you would raise both sides to the reciprocal power. I really don't like that way. It works. It gets you to an answer, but you lose one little idea. Where is it? Right there. Most people forget to put the plus or minus because they don't understand that this 2 in the bottom is a square root. And you just square rooted both sides of the equation. So this is probably the safer way to do it. So you get all your answers and it comes out rather nicely. Even I have forgotten to put plus or minus on a 3/2 power. So this way is much safer. Aren't these ugly? Let's see, do I have another good one? Nah, that's decent. Other equations that are actually nicer. Absolute value equations. These are simpler, if you can remember everything. The danger is about 20% of students forget half of the problem. When I give an absolute value equation, technically it has 2 solutions, but 20% of people give me just one of them. So you have to be really careful when you see absolute values. You've got to start thinking what's really going on. Step number 1. If I give you the absolute value of x, what's it equal to?
X.
All the time? Because remember, x can be positive, negative, 0.
Yeah,
No,
because
that's
the
what-
absolute value makes it positive.
It makes it positive. So if I say the absolute value of x is equal to x, and I say x is equal to -3, then you just said the absolute value of -3 is -3. See what I'm saying? So it can't just be directly x. It's x if x is positive, but it has to change when x is negative. So this actually gets a split definition. It's equal to x if x is positive. So, really important. When you see x is greater than or equal to 0 or anything is greater than or equal to 0, in English this reads is positive. Don't read it as x is greater than or equal to 0 because that means absolutely nothing to most human beings. So, when x is positive, it pops out as x. So the absolute value of 3 is 3. What happens if x is negative?
Exactly.
The absolute value of -3. I know my answer is positive 3. So how did it change? How do you make it negative?
2 negative, multiply 2 negative.
Multiplied by a single negative. So this becomes negative x. So when you're solving an absolute value equation, the way I teach it is purely by the definition of what it means to be an absolute value. So, for example, if I have the absolute value of 2x plus 7 is equal to 8. I do this totally different than the book. If you're going to do it the book method, don't do my method and the book method at the same time. My method is assume that the number on the inside is positive. If 2x plus 7 is a positive number, how does it come out? As itself. See, if x is positive, it just comes out as plain old x. So if 2x plus 7 is positive, then it comes out as 2x plus 7, and it happens to be equal to 8. The other assumption is, well, what if 2x plus 7 is a negative number? There's ways of doing that. X equals -10. That would make it a negative number. If x is negative, how does it have to come out? Well, you have to change its sign. Well, how do you change the sign of 2x plus 7?
So,
Yeah, so it becomes change everything. And the other side, don't change it at all. Now the book does the shortcut, which is change the other side. That gets dangerous with inequalities and double inequalities. So I try to teach it a way that doesn't cause errors later on. But if you do it the book way, it becomes 2x plus 7 equals -8. But I find that confusing personally. Solve both equations. Subtract 7 and you get 2x is equal to 1. Divide by 2 and you get x is equal to half. That's the answer I generally get from 20% of the class, and they forget the other half. So if you come over here, add 7 across, you get negative 2x is equal to 15, and x is equal to some ugly negative 15 over 2. So since it has two solutions, I generally want to group them to say these are both solutions to this inequality, or this absolute value equation. Not that hard, right? Much easier than this.
Oh, that's it?
That's it. Done. Nothing else. Think you can do it? Oh, you can do it. Following the same steps, get me the solution to this. Oops, it went off the board. The absolute value of 3x minus 5 equals negative 2. The absolute value of 3x minus 5 is equal to negative 2. Y'all have an answer? Awesome. Split it into a positive part, pull the inside out as it is. Split it into the negative part, pull the inside out as its opposite.
Let's do it. It's 3x plus 5.
Negative 3x plus 5. You gotta change its sign. You done right? No.
Yes, it is.
Mm-mm. I'm being serious. It is absolutely
Why is
wrong.
that wrong?
I'm not telling you.
Why don't you have to tell me?
I will eventually. Don't you have to tell me?
You see, that's where I was talking about. You see, I forgot my negative right there, but I put it up there and I didn't put it down.
That's fine.
That's
Still
that crazy lady
I
would get me about.
know.
Was this right?
I wonder my grade.
Nope. Nope. You're hiding it.
I know. I don't know, so I'm asking you. Oh.
I love that.
I do too.
I don't think I've ever had a student walk out in the middle of the class
Can't
with
do
me.
that.
So sad. Everybody got an answer?
Yeah.
The answer is there is no answer. Why? It's equal to a negative. How can an absolute value equal a negative number? That's impossible. You're saying the absolute value of this number is equal to negative 2, but the absolute value of every number is positive. The solution to this is absolutely no solution whatsoever. In other words, you didn't have to do a lick of work. You just had to look at it and go, oh, positive number on one side, negative number on the other side? Impossible. Now, if you went through and you got answers, plug them back in and see what happens. What happens is you'll get 2 on this side, and it's equal to negative 2, and that makes absolutely no sense. So be careful with absolute values. They have to equal positive numbers. Now, that doesn't mean, don't do this one, but if I give you something like this, don't tell me it doesn't have any solutions, because this one does. Just because all of this mess on the left-hand side equals a negative number, that's irrelevant. You have to get the absolute value by itself. Number one mistake with this one. I have seen people distribute a negative 3 into an absolute value. You cannot do that. These are not parentheses. These are prison bars. Yeah, that's a good way of putting it. These are prison bars, and he's visiting, but he can't get in unless he does something really bad. So if you bring him in, he did something really bad. So you can't distribute the negative 3, so the best you can do is add the 5. That makes that side negative 2, right? But then eventually you're going to divide by negative 3, and negative 2 divided by negative 3 is positive number, so you're perfectly safe. So be careful with that. But that's absolute value equations. They're really not that hard. Oh, yeah, these. What time is it? I got time. Half hour. Lots of examples of these, short little ones on the web. So if you get stuck, I have the U substitution ones, the quadratic form ones, the absolute value ones, the ones I'm going to show you now, which are horrid. These are bad. Some of them are simplistic, but some of them are really bad. These are equations with radicals. And what I mean by radicals is not square root of 2, but something like square root of x or square root of x minus 2. Some kind of global radical equation. So we'll start you off with a simple one. The square root of 7x minus 10, and I say that's equal to x. Remember, this is the simple one. Oh, I gotta be done in 15 minutes. We have a quiz today. I forgot about that. Word problems, remember? Word problem quiz. So, what do you think the first step is? Square it. Like, if it was a perfect square, we would square root it. Here it's a perfect square root, so squaring sounds reasonable. Take both sides of the equation and square it. It's legal. But it does cause one small problem. If x is negative and you square it, what does it become? Positive. So if x was a negative number in our equation, it's turning into a positive number. It might give us a solution that does not actually exist. It's called an erroneous solution. So there is a danger of squaring both sides of an equation. It gives us that one small possible error. So we have to check for it. So square both sides. This side becomes 7x minus 10. This side becomes x squared. Nice little equation, no radicals, it looks pretty. What do you do next? Move this to the other side, so it becomes 0. I'm going to rewrite it this way though. X squared minus 7x plus 10 is equal to 0. Because we would subtract 7x and we would add 10 to the x squared term. And then hopefully, and more than likely, it factors. So factors of 10 to add up to 7. That's easy. So x minus 5, x minus 2, and therefore x is equal to 5 and x is equal to 2. But that danger of squaring both sides, it sticks in the back of my mind. I need to check these. So you go, take 5, put it back up. 7 times 5. 35 minus 10. 25 square root. 5. And then on the other side, obviously x would be 5. So 5 equals 5, you're perfectly safe. Try 2. 7 times 2. Minus 10, square root of 4, and obviously the other side is 2. Both of these solutions work out, so I'm going to include both of them in my solution set. Ta-da! That wasn't that hard, right? And generally, these don't get too bad except for one case. We'll see him eventually. Make it a little bit more difficult. 2 plus the square root of y plus 10 is equal to y. Should we square both sides right away? No. There's a sub-step, and the sub-step is to get the radical, just a radical by itself. Not the variable, but the radical. So if I want the square root of y plus 10 by itself, I need to move that 2. If you square both sides right now, it gets really horrible. So move the 2 over and you get the square root of y plus 10 is equal to y minus 2. And then commence with the fun. What do you do to both sides? Square it. So we square the left and square the right. The left never causes problems, the right will. Be careful, this is y minus 2 times y minus 2, and you have to FOIL it out. It's not y squared plus 4. All right, so if we square both sides, the left-hand side becomes this side.
Oh,
Y plus 10, left side, equals y squared minus 4, the variables y, plus
No.
plus 4. Yeah, because it would be negative 2 times negative 2. All right, now what? Move everything under one side, keep the y squared positive. So the y and the 10 come over, and you get a big fat 0 equals y squared minus 5y minus 6. You're falling apart. And this factors rather nicely. Factors to 6 and subtract up to 5. 6 and 1. 3 and 2 don't work because they subtract up to 1. So be really careful. Factors of 6 and subtract up to 5 are y and a 6 and a y and a 1. And it's a negative 6 and a positive 1. Yay, that wasn't that bad. So y is equal to 6 is one possible solution, and y equals negative 1 is another possible solution. Just because the answer is negative does not mean it's not a solution, so be careful of that. It's because after you plug it in, it might not be a solution. Let's try 6. Y. 6 plus 10. Square root of 16. 4 plus 2. 6, so it balances out rather well. Negative 1. Negative 1 plus 10 is 9. Square root of 9. 3 plus 2. But 5 is equal to y, which was equal to negative 1. That makes absolutely no sense. So this one goes away, not because he's negative. I want to emphasize this. It's not because he's negative. It's because when you plug it in, it doesn't balance the equation. There is a way of writing this so that the negative answer works and the positive answer doesn't. All I would have to do is take that y minus 2 and make it 2 minus y. So the y would be in that second position. So the only solution to this one is y equals 6. That's not hard, right? How much time? Woo, I still have some minutes. I don't have enough room. This one takes up some space, so if you're at the bottom of your notes, you might want to turn the page. This is the hardest one. And it's horribly it just looks horrible. Very long, very messy. So, example. The square root of 8x plus 17 minus the square root of 2x plus 8 is equal to 3. Now, why is this different than the other two? 2 square roots. That makes it twice as hard. Not horribly so. I mean, methodology. I can't even say the stupid word. You know what I mean. Step by step, it's not too bad. I can't. English language. But the idea has to stay the same. I need to get a square root by itself. Now, I can't have both of them on the same side. That keeps them together, and I don't have one by itself. So force one to be by itself. Which one do you want to isolate? Methodically. There we go. I got it. So which one do you want to get by itself? I would leave this one on this side. It's positive. Move the other one because it's negative to the other side. So leave the square root of 8x plus 17 and let it equal 3 plus the square root of 2x plus 8. Try not to write that as the square root of 2x plus 8 plus 3 because sometimes people think that 3 is underneath the radical. They'll add the 3 and the 8 and they'll change the entire problem. All right, now what can I do? Well, once you isolated the square root over here, what did you do to both sides? Square it. Do the same thing. Square this side. That's not that bad. Square this side. That's not so nice. All right, so you square 8x plus 17. What do you get? Well, the square root of 8x plus 17. 8x plus 17. That's a nice side. The other side I might want to write out. So I'm going to remove the square and write it twice. So this is 3 plus the square root of 2x plus 8. So I can see what's going on a step-by-step basis. First step, FOIL. 3 times 3. 9. 3 times the square root of that mess. 3 times the square root of that mess. So this would be plus 3 square roots of 2x plus 8. And then we're done with the 3, so the next one up is him. So the square root of 2x plus 8 times 3, better known as 3 times the square root of that mess. So you get that one. So that's first, outer, inner. And then last, the square root of 2x plus 8 times the square root of itself, basically. What happens?
2x plus 8.
The square roots go away, and you just get the 2x plus 8. So you get plus 2x plus 8. Ooh, that's horrid. Now what? Combine like terms. Anytime you do the distributive property, your next step better be combine like terms. So 8x plus 17 over here equals 17. I'm going to put the 2x first. Plus 6 square roots of 2x plus 8. Yay! It looks a little bit better. Now what? Did that. Well, basically what happens here is you're starting all over again with a new equation. What kind of equation is this? Well, it's a square root equation. So what should be your instinct? Get it by itself. So I need to move the 17 and the 2x to the other side. So shift these two over. And let's see, that becomes 8x minus 2x. 6x. 17 minus 17. Oh, that's nice. 0. Equals 6 times the square root of 2x plus 8. Now sometimes you have a choice at this point. Sometimes the number that's in front of the radical does not move over very nicely. You can leave it where it is. But when you square both sides, like in this case if I squared both sides, that 6 in front of the radical has to change into 36. You can't just leave it as 6. But that's a danger of leaving it there. So if you can, divide both sides by 6 to get the radical by itself, and you get x is equal to the square root of 2x plus 8. Done? Start all over again. Square both sides. So you square this side, you square this side. Seems like we've been doing this forever. So you get x squared is equal to 2x plus 8, and we're almost done. Next step. So you get positive x squared minus 2x minus 8 is equal to 0.
X plus, factor.
Factor, I know. X what?
X plus x. X minus 4 plus 2.
X minus 4 and x plus 2. Factors of 8 that subtract up to 2. 4 and negative 4 and positive 2. Whew. I'm almost out of breath there. So your two answers, possible answers, are x is equal to 4 and x is equal to negative 2. But do they both work? Let's try 4. 8 times 4. 32 plus 17. Thank God you can pick up a calculator. 49. That would be 7. 2 times 4. 8 plus 8. Square root of 16. What was the first answer? I forgot already. 7. 7 minus 4 is 3. That one works out perfectly fine. So x equals 4 is fine. Negative 2. 8 times negative 2. Negative 16 plus 17. So we just get 1 there. Negative 2 times 2 is negative 4 plus 8 is 4. Square root of 4 is? And 1 minus 2. Negative 1. But it doesn't equal 3. So he's not an answer. Not because he's negative, But because when you plug them back in, it forces an impossibility. Ta-da! So that whole thing has one answer, and it's 4. Isn't that exciting?